The next property is the time shifting property. Okay, this is a very important property. They have also asked this property in one of the question papers. There the question was state and derive the time shifting property of Laplace transform. Okay, so this is the statement: if the Laplace transform of x of t is equal to x of s, and the Laplace transform of x of t minus a is equal to e raised to minus as into x of s. Okay, this is a very important property. That is, if there is a time shift in the signal, then this is equivalent to a multiplication of the exponential function in the frequency domain. Okay, time shift means shift in time domain is equivalent to multiplication of exponential in the frequency domain. Okay, now next I want you to look at the value. Okay, so here if you look very carefully, the shift value over here is minus a. Okay, so that means if the shift value is minus a, then the power of the exponential is also minus a. It will become e raised to minus as into x of s. So that means if the shifting value is negative minus a, then the power of that value, the power of the exponential function is also minus a. Okay, so that means if here it is positive, then here it is also positive. That means the Laplace transform of x of t plus a is equal to e raised to plus as x of s. So see, so whatever the value that you see over here, okay, whatever value, the number that you see over here, minus a or plus a, or whatever value that you see over here, the same value will be at the power of the exponential function. Okay, so here is the proof of the time shifting property. Here first I'm going to apply Laplace transform to x of t minus a. So it will be integral minus infinity to plus infinity x of t minus a into e raised to minus st dt. Okay, so then I'm going to substitute. Let t minus a is equal to p. Okay, t minus a. So that means I'm going to substitute all the values of t minus a into p. So that means this will become t minus a will become p, and here t will become p plus a. Okay, t will become p plus a. Right, so I have substitute p here and p plus a. Then the next step, I'm going to divide this into two factors, e raised to minus sp and e raised to minus sa. Okay, and this is integration with respect to dp. So that means this e raised to minus as is a constant, so I can take it outside. So it will become e raised to minus as integral minus infinity plus infinity x of p into e raised to minus sp dp. Okay, so as you all know, if you look over here, this is nothing but integral minus infinity to plus infinity x of t into e raised to minus st dt, right? As long as this equation is concerned, this p and t is just a variable. As long as the mathematics part side is concerned, p and t are nothing but variables. So this is nothing but x of t into e raised to minus st dt. Okay, so this is also the Laplace transform, right? So this is x of s. So this is how you get the equation. The Laplace transform of x of t minus a is equal to e raised to minus as into x of s. In other words, if the shift, whatever the shifting value that you see over here, the same shifting value you can put it over here. Okay, so